Question 11.1 of the chapter Dual Nature of Radiation and Matter of the textbook Physics, NCERT Physics for class 12. In this question, it has been asked to find the maximum frequency and the minimum wavelength of X-rays produced by 30 kilovolt electrons. We know that when fast-moving electrons are suddenly blocked by a metal target, X-rays are emitted. And this process is called Bremsstrahlung. In this process, some of the kinetic energy of the electrons is imparted to the X-rays, while the rest is used up in heating the metal target. X-rays of maximum energy will be generated in the process if the entire kinetic energy of the electrons is transferred to the X-rays without wasting it in heating the metal target, which means whatever is the energy of the electrons, that will be completely given to the X-rays produced, and no energy is being used up in heating the metal target. This is the condition which is being considered in the present problem. It has been asked to find the maximum frequency and the minimum wavelength of the X-rays which are produced by 30 kilovolt electron. So the X-ray photons will have this maximum amount of energy which is possessed by the electrons, that is E, capital E, which is E times V, and that is V is 30 kilovolts, so it is 30 kilo electron volts. Now, according to the dual nature of radiation, energy associated with X-ray photons is given by the relation E is equal to h nu, which means that energy E is equal to h nu, where h is the Planck's constant having a Worf value 6.626 into 10 to the minus 34 joule seconds, or 4.1357 into 10 to the minus 15 electron volt seconds, and nu is the frequency of radiation. As per this relation, energy is directly proportional to the frequency of radiation because h is constant here. So higher the energy, higher the frequency, the more is the energy associated with the X-ray photons. So in the present case, the energy associated, the maximum energy of the X-ray photons, which is 30 kilo electron volts, would lead to an X-ray of maximum frequency. So we can write this expression that E, which is 30 kilo electron volt, to be equal to h nu max. Nu max is the maximum frequency of the X-rays produced. Nu max can be given as 30 kilo electron volt divided by h, which is 4.1357 into 10 to the power minus 15 electron volt seconds. By dividing these values, we get this to be 7.254 into 10 to the power 18 per second. That is 7.254 into 10 to the power 18 hertz. Thus, the maximum frequency of the X-rays produced is 7.254 into 10 to the power 18 hertz. This is the answer to part A of the question. Coming to part B, we know the wavelength and frequency, the wavelength lambda and frequency nu of a wave is related to its speed of propagation v by the relation nu lambda is equal to v. Now, electromagnetic waves such as X-rays, they travel with a speed c, that is the speed of light in free space. So we can write this formula for X-rays to be nu times lambda is equal to c. Now, since c is a constant, nu is inversely proportional to lambda, which means maximum frequency. Thus, maximum frequency means minimum wavelength. So, the maximum frequency of the X-rays produced by this 30 kilovolt electrons would represent the minimum wavelength of the X-rays. So, lambda minimum would be C by nu max, and nu max we have already determined, putting the value of C as 3 into 10 to the power 8 meter per second and nu max as 7.254 into 10 to the power 18 per second. We get this value of lambda minimum to be 4.14 into 10 to the power minus 11 meters, which is 0.0414 nanometers. Thus, the minimum wavelength of the X-rays produced is 0.0414 nanometer. This is the answer to part B of this question. Thank you.